Newton's second law starts with a vector equation. The sum of external forces equals mass times acceleration, written as sigma F equals ma. Direction matters. Acceleration always points in the direction of the net force, not the velocity. To actually solve problems, that single vector equation becomes component equations. Sum of forces in x equals max, and sum of forces in y equals may. That step turns geometry into algebra. Everything flows from a free body diagram. You isolate one object, replace every interaction with a force, label them, choose axes, then resolve components. Only forces acting on that object go on the diagram. Forces never cancel unless they act on the same object, which is a common exam mistake. Friction needs special care. Kinetic friction has a fixed magnitude, mu k times the normal force. Static friction adjusts itself, anywhere from 0 up to mu s times the normal force, depending on what's required to prevent motion. Its direction always opposes motion or impending motion, not applied force. On inclined planes, rotate your axes so one axis is parallel to the surface. Gravity stays straight down, but its components become mg sine theta along the plane and mg cosine theta into the plane. The perpendicular direction is usually equilibrium, which lets you solve for the normal force cleanly before finding acceleration. For multi-force problems, follow the same workflow every time. Free body diagram, axes, components, Newton's second law, constraints, solve. Here's a worked example. A block on a rough table has two applied forces pulling to the right, one angled up, one angled down. The upward component reduces the normal force. The downward component increases it, which directly changes friction. Solve the y direction first to get the normal force, compute friction, then use the x direction to find acceleration. Newton's laws work as a system. The first law is just the second law with zero net force. The third law explains force pairs, which act on different objects and never cancel on a single free body diagram. Challenge problem. Two masses on an ideal Atwood machine. Draw separate diagrams, write F equals ma for each, eliminate tension, and solve for acceleration and string tension.